Hello, in this video we're going to look at the GCSE IV characteristics required practical. You can see here on my board that I've got various different components. I've got 4 cells wired in series, and that potentially will give me a 6-volt output for our circuit. Also got a switch. We've got 2 multimeters. One will be using as an ammeter, one will be using as a voltmeter. We've got a 10 ohm fixed resistor, and we've got a variable resistor here. So if I bring that closer, you can see the circuit symbol here. So the variable resistor I'm using is a potentiometer. It's rated at 100 ohms, and you can see that I've put 2 little markers here. I'm going to use 5 different settings. So I'm going to use the minimum, I'm going to move it to the white mark, up to the circuit symbol, to my second white mark, and then to the maximum here. So I've got 5 different readings that I can take using my variable resistor. Okay, so let's set up our circuit for this activity. We're going to connect our switch from the negative side of our supply here. So from the black negative terminal, I'm going to connect a lead to the terminal on the switch. We're going to put a lead from the switch to a terminal on our resistor. Then we're going to connect a lead from our resistor to one of our multimeters, and we're going to use this one as an ammeter. So if I bring that closer, you can see here that we have an amps DC scale, and we're going to use the 10 amp setting, and we've got 3 sockets on our multimeter, one marked COM. We always put a lead into COM when we're putting our multimeter into the circuit, and the other socket we're going to use is the one marked 10 amps. Okay, so if we follow conventional current, we need to wire our lead into the COM socket, and then we need a lead from the 10 amp socket of our multimeter to go into our variable resistor, and then a lead from our positive terminal of our cell bank here to go into the other terminal of our variable resistor. So now our circuit, we have a series circuit wired up here, and our switch is open and our ammeter is switched off. So let's switch our ammeter to the 10 amp setting and switch our circuit on, and you can see that we have a reading here of 0.24 amps, and that's with our variable resistor on its setting on our low setting here. Now what we need to do is we also need to incorporate our other second multimeter, which we're going to use as a voltmeter. So let's bring that closer. You can see here that we have a volts DC scale, and we're going to use the 20 volt setting. Again, we've got our 3 sockets, one marked COM, so we're going to use that. The other socket we're going to use this time is marked volts, ohms and milliamps. And we're going to put our voltmeter across our resistor, so we're going to wire it in parallel. So we put a lead from COM into our socket here, and a lead from the volts, ohms and milliamp socket. We're going to put it into this terminal here. We switch it on to 20 volts DC, and we switch our circuit on. So here we can see that we have a reading of 2.48 volts. We'll switch the circuit on and we have a current of 0.24 amps. So it's important to switch your circuit on and off. You don't want to allow the resistor to get too warm. So now we're going to move our variable resistor to its second position. Switch our circuit on. We have a reading of 1.34 volts and a current reading of 0.12 amps. We switch our variable resistor to the third reading setting. So now we have a potential difference across the resistor of 0.79 volts and a current of 0.07 amps. I move it to the fourth reading position on our variable resistor, switch the circuit on, we have a reading of 0.57 volts and a current reading of 0.05 amps. Switch the circuit off, we go to the maximum on our variable resistor, our fifth reading setting, switch the circuit on, and we have a reading of 0.49 volts and a current reading of 0.04 amps. Switch the circuit off. Now you could repeat those readings at least twice for each variable resistor setting. So that's looking at the characteristics of our resistor. So we can try a different component. This time we can use a bulb. So I'm going to switch our multimeters off and I'm going to disconnect our resistor. This time I'm going to bring in our bulb. So this is a 3.8 volt bulb. We're going to just connect it in so we can keep the leads exactly the same. So again, I'm going to switch our voltmeter to 20 volts DC and our ammeter to 10 amps setting there. So again, I've turned our variable resistor to the first reading marker. Switch our bulb on. This time we have a voltage reading of 5.04 volts and a current reading of 0.07 amps. Switch the circuit off and move the variable resistor to the second reading setting. Switch the circuit on and now we have a reading of 3.72 volts and we have a current of 0.06 amps. Switch the circuit off and now we go to our third setting on our variable resistor. We have a reading now of 2.5 volts and we have a current reading of 0.04 amps. Go to our fourth reading, switch our circuit on. We have a voltage reading of 1.78 volts, and we have a current reading of 0.03 amps. And then we go to our fifth reading position, switch the circuit on. We have a voltage of 1.46 volts and a current reading of 0.03 amps. Okay, so that was using a 3.8 volt bulb. What I can do is, if we change that, I can incorporate a 6 volt bulb. So if we move our variable resistor back to its first setting, we switch our circuit on, and we have a reading of 4.93 volts and 0.08 amps. Let's go to our second setting on our variable resistor, switch the circuit on, and we have 3.59 volts. We have a current reading of 0.06 amps. Go to our third setting, switch our circuit on. We have a voltage reading of 2.37 volts and a current reading of 0.05 amps. We switch our circuit off. We go to our fourth setting, switch our circuit on, and we have a reading of 1.63 volts and a current reading of 0.04 amps. And then our final fifth reading from our variable resistor, we can switch our circuit on, and we have a reading of 1.34 volts and a current reading of 0.03 amps. Okay, now what we can do is we can swap part of the activity. It asks you to swap the leads. So what we're going to do is we're going to disconnect these leads here, and I'm going to put in long lead. Need to be able to get over to the switch. So that's fine, so we'll put that long lead in there now. We're going to disconnect this lead here. And we need to find a long lead from the negative terminal of our battery, and this time we're going to connect it to our variable resistor, and we're going to connect the lead from the positive terminal of our batteries here to the terminal on our switch. So we've reversed our connection. So let's go back to our first setting on our variable resistor, switch our circuit on, and this time you can see that we have a negative reading of 4.93 volts and a negative reading here of 0.07 amps. Go to our second setting, and we have a reading of negative 3.6 volts and a negative 0.06 amps. Go to our third setting. We have a reading of negative 2.38 volts and a negative reading of 0.05 amps. To our fourth setting, we have a negative 1.63 volts and a negative 0.04 amps. And our final fifth reading setting, switch the circuit on, and we have negative 1.35 volts across the bulb and a negative 0.03 amps for our circuit. Now we can reintroduce the resistor and show if that get our readings while our circuit is connected this way. So if I put our variable resistor back to its first setting, switch the circuit on, and we have a negative reading on our resistor of minus 2.49 volts and a current reading of minus 0.24 amps. Go to our second setting, switch the circuit on, and we have minus 1.30 volts across our resistor, and we have a reading of minus 0.12 amps. So our third setting, switch the circuit on, negative 0.81 volts and a current reading of negative 0.07 amps. So our fourth setting, switch our circuit on, and we have a reading of negative 0.58 volts and a current reading of negative 0.05 amps. And then our last reading, we have a voltage of negative 0.49 volts and a current reading of minus 0.04 amps. So by using this circuit, we've looked at the IV characteristics of a filament bulb and a resistor.